Hello students, welcome back. I am Rinkesha, a mathematics teacher, and today we'll start with exercise 2.3. In our last video, we had completed about functions and types of functions. So now today we will complete exercise 2.3 based on the theoretical concepts that we have studied in the last video. Okay, so let's start with question number 1. Question number 1. Which of the following relations are functions? Give reasons. If it is a function, determine its domain and the range. Okay, so let's start with the first part of question 1, which is the first sub question. Here it is given the ordered pair 2, 1, 5, 1, 8, 1, 11, 1, 14, 1 and 17, 1. Right? So if I draw an arrow diagram, right? If I draw an arrow diagram, okay, let this be the first, which includes the first element, that is the domain. It includes 2, 5, 8, 11, 14, and 17. And in the codomain part, let's include the range, that is the second element, 1, 1, 1, 1, 1. So it's only having 1. Okay, now if I take the relation, 2 is related to 1. 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. You know, see here, every element of domain is related or is having only one image. Okay, so what was the definition of function? Definition of function means the first element of the set will have one and only one image, right? Every element of the domain will have one and only one image. So that is satisfying. So yes, this is a function. Okay, now let's write down its domain and range. So domain of the function will be equal to all the first elements of the ordered pair, that is 2, 5, 8, 11, 14, 17. Clear? And the range of the function, that is the second element, that is only 1. It is common in every ordered pair. So this is the domain of the function and the range of the function. Clear? So note down the first part of question number 1. Okay, now let's move to the second one. The second one is, here the ordered pairs are 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, and 14, 7. So again draw the arrow diagram. So now let me write down the elements. The first element is 2, 4, 6, 8, 10, 12, and 14. Second, 1, 2, 3, 4, 5, 6, 7. So now when I will solve the relation, 1 is related to 4 to, sorry, 2 is related to 1, 4 related to 6 related to 3, 8 to 4, 10 to 5, 12 to 6, and 14 to 7. So here also, right, here also each element of the domain is related to or is having one and only one image. So I will also say this is a function. Yeah. Now the domain of the function. So the domain of the function d of f will be equal to the first elements or I can write down directly from this: 2, 4, 6, 8, 10, 12, and 14. The range of the function. So there are the images of the elements of domain: 1, 2, 3, 4, 5, 6, and 7. Clear? Okay, so these are the domain and range. Okay, just note it down. Okay, now let's move to the next one, that is the third question of question number 1. Question number third. The ordered pair given here are 1 3 1 5 2 3. So I will draw an arrow diagram. Okay, the elements in the domain, I will have 1, again 1, so I will not repeat it again, and 2. Here 3, 5. Now see, when I will draw a relation, 1 is related to 3. 1 is also related to 5, and 2 is related to 5. See, 2 is having only one image, but 1 is having two images, right? So according to the definition of function, it must have only one image, but one is having here two images, so this is not a function, right? So it is not a function, so no need to write down the domain and the range. Clear? So just note down question number third of 1. Now let's move to the second question. Question number 2. Find the domain and range of the following real function. Now see, it is given the question following real function. So the first one, right, it is given fx is equal to minus modulus of x. Now see here, which value of x I can take. As it is a real function, I can take those value of x in which minus of modulus of x is possible. Now, for every real number, minus of modulus of x is possible. That means x belongs to R for domain. So, domain of the function is equal to R. Clear? So, this is the first part. Now, you also have to find out the range, right? So now see here, modulus of x, that will be always greater than equal to 0. So what does that implies? Modulus of x belongs to 0 to infinity, because it will have only a positive value. But now putting a minus sign, putting a minus sign ahead of the modulus of x, that means your answer will be negative. Okay, unless it is a 0. If it is a 0, then the answer will be 0. So at this case, it will be equal to minus infinity to 0. Here also it will be close bracket, right? So the range of function here, this will be equal to minus infinity to 0. Clear? So this was only the first part, so just note it down. Now let's move to the second part of question number 2, means second sub question of question number 2. Second is fx equal to square root of 9 minus x, right? So now see, here I have to take such value of x so that square root of 9 minus x is possible. Now we know that square root of negative number is not possible. That means 9 minus x square must be greater than equal to 0. So that means 9 must be greater than equal to x square. Now we know that 3 square is equal to 9 and minus 3 square equal to 9. Any number greater than 3 will have a square value greater than 9. So that means the value of x must be less than equal to 3, right? On the other side, if the value of x is less than minus 3, let's take minus 4, then it will be 16. Again, it will be greater than 9. So the another limit will be x must be greater than equal to minus 3. Clear? So the value of x lies between minus 3 and plus 3. So the domain of the function, the value of x that we can take is minus 3, sorry, close bracket minus 3 to plus 3. Okay. Now for the range. Okay. So see, this is the domain. So let me draw a table for that. X and f of x. That means the root of 9 minus x squared. So let's see which value of x I can take. The lowest value of x that I can take is minus 3, because minus 3 is the lowest value. Then I can take minus 2.5. Okay, but let me write down the integers value only. Okay, the answer will lie between the answer of these two: minus 1, 0, 1, 2 and 3. So it's minus 3. It will be 9 minus 3 square. So 9 minus 9, 0. When I put minus 2, so 9 minus 4, that is 5. Minus 1, 9 minus 1, 8, 0. 9 minus 0, 9. Again 1. Answer will be 8. When I put 2, it will be 5. When I put 3, 0. So see here, as it is a real function, it's not that I can only take integers. I can also take 1.5. But when I will take 1.5 here, the answer will range between 5 and 8. Right? So what is the lowest value? The lowest value I got here, that is equal to 0, and I can take 0, so I'm using close bracket. Okay, and the highest value I got here is 9. So the range of this function, that is, it lies between 0 and 9, provided 0 and 9 are also included. Here, this was the second part of question number 2. Just note it down. Now let's move to the next question, that is question number 3. The function f is defined by fx is equal to 2x minus 5. Okay, so you have to find out 3 questions in that. So first is f of 0. See, I will write the same function, but at the place of x I will put bracket. Now see, here it was x, so here it is x. So here it is 0, in the place of x I will put 0. So 2 into 0, 0 minus 5, minus 5. Okay, now the second one, that is f of 7. Same method, 2 instead of x I will use bracket. And here it is 7, so I will fill the bracket by 7. 7 is a 14, 14 minus 5, that will be equal to 9. Now the third one, f of minus 3. So 2 instead of x I will bracket minus 5. So here is minus 3, here I will put minus 3. 2 into minus 3, that is minus 6, minus 5, it will be equal to minus 11. Clear? So this was about question number 3. Note it down. Okay, now let's move to the next question, that is question number 4. Question number 4. Okay, here the function T which maps the temperature in degrees Celsius into temperature in degree Fahrenheit, that is defined by the function T of C equal to 9 by 5C plus 32. Now there are 4 different questions asked. So let's start with the first one. First, you have to find out T of 0, means at 0 degrees Celsius, or 0 degrees Celsius equal to how many Fahrenheit. So I'll use the method that I had used in the third question. Instead of this C, I will put bracket plus 32. Now, as here it was C, I got here C. Here it is 0, so I will put here 0. So 9 by 5 into 0 is 0 plus 32, that will be equal to 32. So that means 0 degrees Celsius, that is equal to 32 degree Fahrenheit. Clear? So note down the first question of question number 4. Now let's move to the second one. The second question is T of 28. So 9 by 5 instead of say 28 plus 32. Here, so let me calculate it. It's 9 into 28 divided by 5, that is equal to 50.4. So this is equal to 50.4 plus 32. So this will be equal to 82.4. This means that 28 degrees Celsius, that is equal to 82.4 degree Fahrenheit. Yeah. So note down the second sub question of question number 4. Now let's move to the third one. Question number third is T of minus 10. So 9 upon 5 instead of C minus 10 plus 32. Okay, so 5 ones are 5 minus 2 is there. So now 9 into minus 2 minus 18 plus 32, so that will be equal to 14. That means minus 10 degrees Celsius is equal to 14 degree Fahrenheit. Yeah, so this was about the question number third. So just note it down. Now let's move to the next question of question number 4, that is the fourth one. Question 4 is the value of C. You have to find out the value of C when T of C is 212. That means at what degree Celsius or what degree Celsius of temperature is equal to 212 Fahrenheit. Clear? So here question 4, T of C, that is equal to 212. So let me use the formula 9 by 5 into C plus 32, that is equal to 212. Yeah, when I take 32 on this side, it will be subtracted. So 9 by 5C, that will be equal to 212 minus 32. Okay, so I'm taking it here, 9 by 5C, that will be equal to 212 minus 32, that will be equal to 180. So now we'll just take 5 on this side, it will be multiplied, and 9 on this side, that will be divided. Right? So C is equal to 180 into 5 divided by 9. So 9 ones are 9 twos are 18, so 9 20s are 180. So 20 into 5, that is equal to 100. Right? So this means 100 degrees Celsius, that is equal to 212 degree Fahrenheit. Okay, so this was about the fourth part. Okay, this is about the fourth part of question number 4. Okay, note it down. Okay, now let's move to the next question. That is question number 5. That is the last for this exercise. Question number 5. Find the range of each of the following function. Okay, so let's take the first one. It is fx is equal to 2 minus 3x. X belongs to R, and remember, x belongs to R means you can take any value of x, but x is greater than 0. Yeah. Now we had discussed earlier that fx, we can take fx as y. Okay, so y is equal to 2 minus 3x. So now to find out the range, I need to find out the possible values of y that I will get when I will take x greater than 0. Okay, so now this shows us that y this shows us that 3x equal to 2 minus y. So this implies x equal to 2 minus y upon 3. Okay, now see, it is given that x is greater than 0. So using this equation, I will get 2 minus y by 3 greater than 0. That means 2 minus y is greater than 0. That means 2 is greater than y, or y is less than 2. Right? So the range of this function will be equal to 2, and this, sorry, it's not, it will be open bracket, and here it will be minus infinity. So this range includes the value less than 2, from minus infinity to 2. As it is less than, so I had used open bracket. Clear? Okay, so this was about the first part of question number 5. So just note it down. Now let's move to the next one, that is the second part of question number 5. Second question of question number 5 is fx is equal to x square plus 2, and x is a real number. Okay, so now what I will do, I will take this as y. x square plus 2. So x square is equal to y minus 2. So x will be equal to square root of y minus 2. This means that the value of x, or the value of x, that is square root of y minus 2, square root is only possible of positive number. So this means that y minus 2 must be greater than equal to 0, because square root of 0 is 0. Clear? Then only this function is possible. So this implies y is greater than equal to 2. So the y range that can have any value greater than equal to 2. So the range of the function here is plus 2 to 0. Clear? See here 2 in close bracket because it is greater than equal to. The range of this function is close bracket 2 to 0 open bracket. Okay, so note down the second question of question number 5. Now let's move to the third part of question number 5, that is the last for this exercise. Next, fx is equal to x. Third is fx is equal to x. Now what is this? This is an identity function, right? So whatever value of x will take, we will get that answer in the function. And here it is given x is a real number. So this implies that range of the function will be equal to r, because the domain is r and fx is x, that is the identity function. Here, this was about the third part. So just note it down. Okay students, so that's it for today. Here we completed exercise 2.3. In our next video lecture, we will continue, or will start with the miscellaneous exercise. Thank you.